All right, today we're going to crack the code on something we all use every single day, probably without even thinking about it: global coordinates. Now, these aren't just some random lines on a map, they are the invisible framework that basically runs our entire world, from navigation and trade to, well, time itself. And look, for anyone studying geography or international relations, getting a grip on this system isn't just helpful, it is absolutely essential.
So just think about this for a second. The Earth is a spinning sphere, right? There's no natural up or down, no obvious starting point. So how in the world did we, as a civilization, agree on a single universal system to pinpoint any location and any moment in time? That is the incredible challenge we're going to unpack today. Okay, let's start with the first piece of this massive puzzle: figuring out where we are. Before we can even begin to talk about what time it is, we have to agree on a way to describe our place. And the first step is solving that north to south position.
Geographers came up with a pretty brilliant solution. They used the Earth's own spin to define a natural reference point, the equator. That became our 0-degree line. From there, every other line of latitude is just an angle measured from the center of the Earth. So if a city is at 30 degrees north, it means it sits on a line that makes a 30-degree angle with the plane of the equator. It's actually a really elegant and simple solution to a huge problem.
Now, here's a crucial feature to remember. These lines of latitude are always parallel to each other. You can think of them like hoops stacked around the globe. They never, ever cross. And that parallelism is so important because it gives us a consistent, reliable way to measure distance north or south of the equator. But here's where it gets really interesting. These imaginary lines we've drawn have very, very real consequences. Your latitude doesn't just tell you where you are on a map, it's probably the single biggest factor in determining the climate you live in. You see, because the Earth is a sphere, the sun's energy isn't spread out evenly. Around the equator, the sunlight hits pretty much straight on, creating what we call a heat surplus. But as you move up towards the poles, that same amount of energy gets spread out over a much larger area because of the planet's curve. It's like shining a flashlight directly versus at an angle. This creates a heat deficit. And this simple imbalance of energy is what drives our planet's weather and creates all the climate zones we know. So, okay, latitudes have the whole north-south thing covered, but that still leaves half the problem, right? How do we figure out our east-west position? For that, we need a whole different set of lines: longitudes. And this created a massive headache for early geographers. Unlike the equator, which is a natural halfway point, there is no natural starting line for longitudes. Every single one of them runs from the North Pole to the South Pole, and they're all the same length. So they had to just pick one. They had to arbitrarily decide where 0 would be. But the big question was, which line gets to be the one? Well, the decision wasn't about science or geography, it was all about politics and power. See, back in 1884, at the International Meridian Conference, the world's major powers got together to finally settle this. By that time, the British Empire was a dominant global force, and most of the world's ships were already using maps that referenced Greenwich, London, so it kind of made sense. By a pretty decisive vote, the line running through the Royal Observatory in Greenwich became the official Prime Meridian, the world's 0-degree line of longitude. Now, establishing the Prime Meridian did way more than just solve the east-west problem. In fact, you could argue its biggest impact was that it gave us the master key to creating a standardized time system for the entire globe. And it all comes down to this magic number right here, 15. Just think about it. The Earth spins a full 360 degrees in 24 hours. You do the simple math, 360 divided by 24, and what do you get? 15. Every hour, the Earth rotates 15 degrees of longitude. This beautiful, simple mathematical link is the absolute foundation of our entire system of global time zones. So how does this play out in the real world? Well, let's take India as a perfect example. India's standard meridian is set at 82.5 degrees east. So you take that number, 82.5, and you divide it by our magic number, 15 degrees per hour. And the answer you get is exactly 5.5. Now, because India is east of Greenwich, the sun rises there earlier, so its time is ahead. We add those 5.5 hours to Greenwich Mean Time, and that is exactly how we get Indian Standard Time, or IST. Simple as that. Okay, so if the prime meridian at 0 degrees is the world's starting line for the day, it just makes sense that there has to be a finish line, right? A place where the day officially ends, on the exact opposite side of the planet. And that's exactly what the 180-degree longitude line is. We call it the International Date Line. It's basically the planet's official reset button for the calendar. This is the internationally agreed-upon spot where today officially flips over into tomorrow. All right, now for everyone out there preparing for competitive exams, you'll want to pay close attention here. This is a classic question. If you look at any world map, you'll see the international date line isn't a nice straight line. It kind of zigzags all over the place in the Pacific Ocean. So why? The reason is just plain common sense. If the line were perfectly straight, it would slice right through countries and groups of islands. Imagine if one side of your village was in Monday, but your neighbor across the street was in Tuesday. It would be total chaos. So, to avoid that mess, the line was drawn to bend and weave around land, making sure entire nations like Fiji or Kiribati stayed on the same calendar day. So what actually happens when you cross this line? It feels a bit like time travel. The rule is simple. When you travel west, say from the US towards Asia, you lose a day. You jump forward. Sunday instantly becomes Monday. But if you travel east from Asia towards the Americas, you gain a day. Monday suddenly becomes Sunday again. You literally get to live the same day twice. And so, there you have it. This whole global system, built on these imaginary lines. From the physics that drive our climate to the politics that decided our starting point for time, this grid is really a monument to our need for order. It's this quiet, invisible system that runs almost everything: global trade, travel, technology. So the next time you glance at your phone to check the time or find your location, just take a second to remember the centuries of science, navigation, and politics that made that simple little act possible.